Hello, I am Ruhun De Silva, and this is my lab for oscillations for Physics 2211. So for the introduction, we start with Newton's second law, once again, and the momentum principle, which states that a system's change in momentum is proportional to a net force. And then we also now have the energy principle to use, which is the change of energy is equal to the work plus the change of heat. And then we also derive derived from the momentum principle, we have position and velocity update position formulas, starting with the initial position, adding the average velocity times the change in time. And then the velocity update formula starts with the initial velocity plus the net force over mass times the change in time. That's what it looked like in the computer programming computational part. So the purpose of this lab is to compare predicted motion to observed motion of a spring and being able to plot the change in energies of kinetic and potential. And then what we'll end up seeing is basically that the change in total energy of the system is zero. So here's my tracker model. We have the system, which is the weight, the earth, and the spring. And then for the surroundings, we just have air. You can see here the tracker moves around in almost a circular path, and it starts to act as a pendulum, oscillating in both the X and Y directions. So then for the computational part, it looks a bit like this, where you have the spring position, L being calculated along with the kinetic energy, potential, and total energy. Then for the models of the X position versus time and the Y position versus time, they show that there's almost zero difference between the two of them. And then when you look at the total energy in time, which is the orange line, you can see that there's no change in energy. And that's because the system is closed, and due to the energy principle, the change in energy is simply going to be zero. So possible errors, of course, there could be human errors due to the way it could not be aligned or tracker issues. There's also drag forces due to the air resistance, and also the initial velocity may not have been zero in this case. And for what does this mean? Basically, the total change in energy is zero. This means that the kinetic energy that the energy principle is conserved because the change in kinetic energy, gravitational potential energy, and spring potential are all equal to zero within the system. There's zero work done on the system because all the forces are internal, and then that's because the spring, weight, and earth are all a part of the system. Like we said, the air was the only outside in the surroundings, therefore there's no work done, therefore there's no energy change. And so for the X average, X and Y positions or oscillations, you'll see that once again, they're almost identical, which goes along with what the question we are answering is, with the average X position oscillation being 1.51 seconds and the average Y position oscillating being 0.33 seconds. So basically, in conclusion, we once again looked at Newton's second law of the momentum principle, and now we have introduced the energy principle while we have compared predicted motion to observed motion of the spring, and we're able to plot the change in energies and basically determine that that the total system would have no change in energy. Thank you for listening to my lab 4.